Today we are going to see an important question, that is finding characteristic equation of a matrix. That is a very important question under this topic. For all the problems, we need to find the characteristic equation. That is the first step under this matrices. If characteristic equation is wrong, then the whole problem will be wrong. So today we are going to see how to find out characteristic equation for a given matrix. First problem, A is equal to, I have taken a 2 by 2 matrix. First row 1 minus 1 0 1. So there are two methods to finding the characteristic equation. One is mod A minus lambda I equal to 0. This is the first method of finding characteristic equation. So today I am going to show you the two methods. You follow which one is easy for you. So mod A minus lambda I equal to 0. This is nothing but in the given matrix A, the leading diagonal elements. What are the leading diagonal elements here? Here 1 and 1. So these are the leading diagonal elements. So these elements supposed to be subtracted by lambda. I is nothing but identity. After that we have to expand that, we can get the characteristic equation. So mod in the given matrix, the leading diagonal elements only subtracted by lambda. So it can be written as 1 minus lambda minus 1 0 1 minus lambda is equal to 0. Now we have to expand this. We have to multiply in this direction first. So 1 minus lambda the whole square. When you are multiplying in the upward direction, we have to change the sign. Here it is minus 0 actually. So we have to change the sign. It is 0, which is equal to 0. Then this is nothing but this is of the form a minus b the whole square. So 1 square plus lambda square minus 2 lambda equal to 0. Therefore, the characteristic equation is the characteristic equation is, we will arrange it as lambda square minus 2 lambda plus 1 equal to 0. So this is the answer for the given matrix. Lambda square minus 2 lambda plus 1 equal to 0. And moreover, an important thing is, given matrix is a 2 by 2 matrix, then obviously the characteristic equation is a quadratic equation. If it is a 3 by 3 matrix, means obviously the characteristic equation is a cubic equation. So that one we have to keep in our mind. So now we have completed method 1. We are going to see the next method. The next method is, for a 2 by 2 matrix, the characteristic equation is lambda square minus C1 lambda plus C2 equal to 0. This is the general formation for a 2 by 2 matrix. So here we have to find the value for C1 and C2. Then we can substitute the values in this equation. We can get the characteristic equation. C1 is nothing but, C1 is equal to, C1 is nothing but sum of the diagonal elements. Sum of the diagonal elements, that is C1. So here the diagonal elements are 1 and 1. So 1 plus 1, that is equal to 2. And C2 is nothing but, so C1 equal to 2. And C2 is nothing but modulus of a given matrix. So 1 minus 1, 0 and 1. So we have to expand this. 1 minus is 0. So we can get C2 answer is 1. So now we will back to this equation. You can call it as equation 1. Therefore, from equation 1, lambda square minus, our C1 answer is 2. So 2, here it is lambda, plus our C2 answer is 1 equal to 0. That is the characteristic equation is, lambda square minus 2 lambda plus 1 equal to 0. Now you can see that in both the method we got the same answer. Here also lambda square minus 2 lambda plus 1 equal to 0, and this method also we got the answer as lambda square minus 2 lambda plus 1 equal to 0. You look at these two methods, which one is easy for you, you can follow that one. By the same manner we can do it for a 3 by 3 matrix. that will be given in the next video. The link is given in the description box. You can make use of that. Thank you for watching.